Here we are back with a solution for number 2 from your quiz on Monday, March 30th. This one now is an iterated integral that's given to you. My bounds, it just looks like okay, cool, let me integrate with respect to x and integrate with respect to y. That's the order that's given to me. But when I look at this, the first problem I have, or the first issue, is that I cannot integrate this function. If I start an e to the x squared, dx does not have an elementary function that is its antiderivative. If you're watching this to try to see from the quiz, I had a lot of very creative approaches to try to solve this, but you just can't do it. This was one of the reasons why we had power series and Taylor series and Maclaurin polynomials and all that stuff that was done in Calc 2 was to address the fact that I can't integrate this function, okay? So what I need to do is, when I have a double integral, a dx dy, Fubini's theorem says that I don't have to do it in that order. What I can do is I can switch the order of my differential, so I could do dy and then dx. But I can't just switch them. I need to then change the limits of integration. But if I switch the order, I can't have a variable y be the end part of my integral. So what I want to do is I want to take this information right here and think about what that means for my domain. Where's my region that I'm trying to integrate over? So that means that y. So that's gonna give me, let's see, my y values are going from here to here. And then my x values are gonna go from y equals x to x equals 1. Nope, I totally missed. Hold on, that needs to move over a little bit. So I need to be inside this band, and then I'm bounded here by these two. So it's going to give me this little triangular region over here. So if I'm going to switch the order, that means I want to have my, instead of y being bounded by 2 constants, I want to go my x values. I want to have my x values bounded by a constant, so that I can integrate y first. So that means my x values here are going to go from 0 to 1. And now my y values, so instead of going left to right, having a type 2 region, or a type 1 region, what I want to look at now is a type 2 region, or a type 1 region. I'm sorry, I'm getting those backwards. This is a type 2 region. I want to make it a type 1 region. I apologize for that. So if I look here, my lines, my y values are going from 0 until this function here. So I'm going from 0 to x. So this is my kind of transition, or the way, what I have to do with my bounds so that I can rewrite this. So now I'm going to have my x goes from 0 to 1, and my y values go from 0 to x. I'm going to do dy dx. That's what I have to do in order to switch the limits of integration, or to switch it so that I can do dy dx first instead of dx dy. Because here, I can't integrate this. Now, this is just a constant in terms of y. So what I can do is just this antiderivative is just going to pick up a y value. So this is going to be y e to the x squared evaluated between 0 and x. When I plug in the 0, this is just going to go away. So when I plug in the x here, this now gives me the integral from 0 to 1 of x e to the x squared dx. It doesn't look like it's much different. This is the x here in the front. It doesn't look much different from what we started with over here, but having that x value, this is going to look like a factor. Okay. I only have one integral, so I just need the gx out here. This factor of x in the front is going to now allow me an approach to solve this antiderivative. So if I do a u substitution, I can make a substitution here for the x dx. So I can rewrite this as 1/2 the integral from 0 to 1. So then that gives me e to the u du. So now that gives me my antiderivative of an exponential function is just itself. So this is e to the u over 2 evaluated from, then we plug the x back in, x squared, from 0 to 1. So when I plug in a 1 here, that's going to be e to the 1 over 2, minus when I plug in 0, e to the 0 power is 1/2. I can also write that if you want. There's a couple different ways I can simplify it. I can say that's 1/2 e minus 1. That's actually probably the only other way you're going to simplify that. But if I look here, I don't need the 1 as the exponent because e to the first power is just e. So that was the approach or the idea that you had to do for the problem number 2 on your quiz, is that here I recognize this as I can't solve this, so I need to do something to fix it so that I then can solve it. So my approach to fix it is to switch so that I do dy first, because then what that does is that gives me this extra x variable on the outside. So now I have an integral that I can go ahead and solve in terms of x's. Okay. Questions? Go ahead and send me an email. Solutions are posted on the website for the class. Here's some videos. Let me know how things are going.